our first presentation is the new ARDOT, that's Arkansas DOT dive inspection team. Kevin Weston with the staff-heavy bridge maintenance engineer from ARDOT will be given the first presentation.
Good morning. So I thought about, everybody's waking up this morning. I was thinking last night, what should we do? And I was thinking maybe some morning calisthenics. So, no, I'm just kidding. So, yeah, I'm Kevin Weston. I talked a little bit yesterday about our maintenance group and our heavy bridge maintenance group in Arkansas. So today we're going to be talking on the inspection side of what our office gets to do. And so something we started last year is we have an in-house dive group now. And I'm not up here to tell anybody how to do anything. I'm just saying, up here to talk about what we're doing in Arkansas, some of the success we've had, and some of the areas where we're looking to improve. So hopefully y'all get something out of this. So about this presentation. So we're gonna walk through three things, kind of like my presentation yesterday. We're gonna go through the background information and the need for in-house dive teams. So you got to have a need before you do something. So we're going to talk about ARDOT, so our workflow and the inspection process, and then we're going to talk about some outcome and lessons learned. So again, I'm not saying I'm the expert up here, but I just want to share what Arkansas is doing, and maybe everybody can benefit from this. So again, I want to point out what heavy bridge maintenance is. If you didn't hear my talk yesterday, heavy bridge maintenance is pretty much the centralized inspection and maintenance office for the state of Arkansas. And in our central office, we have our specialized teams, I guess the teams that inspect the major complex bridges, as well as now what I'm going to talk about today is our dive, some of our dive operations. Okay, so more about background information. So the idea for an in-house dive team has been around for many years. It was talked about when I first started, but there were some hurdles to jump through, and we also needed a catalyst. So about a year and a half ago, we had this catalyst in our program when FHWA did a review. We had a plan of corrective action. So they're stating that we need to take an inventory and do a proper assessment and figure out which bridges we actually need to be diving. So that was kind of our catalyst for this. And so the process of this, we used a lot of GIS tools, a lot of MBI data. We were looking at the whole inventory of bridges and figure out which ones all need a dive, and even which ones need some of what we call a dive is like a bobbing inspection. So snorkel, it might be that 4 feet of water that Graham was kind of talking about yesterday. You need somebody in there checking out, piles that are not going to be dry to inspect at some point. All right, so we did some file reviews, some GIS, and we're looking at all the bridges crossing water. Then we looked at every single bridge to determine if it needs a dive or not. And then also part of the PCA, FHWA gave us a 12-month deadline. So we gotta dive all the bridges that are required of us within 12 months. So the primary what we used to solve this was our consultant at the time. So consultants are very helpful, and we had a great one that we were working with, and they stepped up and helped us do a lot of this. But at the same time, we saw the opportunity to do some of this ourselves. Because there's a lot of dives that we're calling dives that are really kind of like bobbing inspections. So we saw an opportunity to do this a lot ourselves because of cost and the low risk for us to do. Okay, so we're going to get into some of the requirements. So there's a lot of requirements involved in diving. So we got FHWA requirements. Everybody knows FHWA. There's a lot of safety requirements, OSHA and things like that. Then you get into training requirements, what's required of us and what we're going to require of our guys, and then documentation requirements. So that's a picture of me. I just threw that in there because that was a couple weeks ago. That is not what Arkansas water looks like. Arkansas is not a coastal state, so if you can see the hand in front of your face at a couple feet, you're having a good day. Okay, so I want to throw this up there, and I'm not going to go into very specifics of this, but for consultants are normally required to be ACDI certified. So as in that's an OSHA, approved way to go for safety that states require or the government requires. But in Arkansas, and it depends on the state, it's about 50-50 around the country. Arkansas is not an approved OSHA, doesn't have an approved OSHA state plan. That means that ARDOT employees don't follow, under direct regulations of OSHA. So that's just something interesting. So that's how it is around the country. But Arkansas falls under, state regulations. So we have state safety regulations that we got to follow. And then I also wanted to put it in here, although we're not held to OSHA safety standards, we're making sure that we are going to meet or exceed those OSHA safety standards. So just some clarification and interesting thing to note. But all consultants, contractors, everybody working for ARDOT have to meet or exceed OSHA, and they fall underneath the regulations of OSHA. Just interesting. Okay, so some of the requirements that we put in place, and I want to pause here. We're not making existing employees, or we didn't make existing employees do this. This was more of a, for years, we had inspectors that talked about it, or inspectors that were divers, or like Andy was a diver already, and he's like, I really want to do this because diving is fun, is a cool use of my time, or a way we can help better our inspection program. So we had volunteers. So these volunteers that were already inspectors, engineers, so we talked with them. There was a consensus and enough of our own, crew members, our own inspectors, our own engineers that wanted to do this voluntarily, that we were able to actually make this come to life. And so out of those volunteers, of course, you got to be evaluated by a medical professional. You can't just have, anybody diving. And then, we did certain certifications, there's CPR, there's the actual diving, learning how to dive. There's FHWA requirements, you got to take the underwater class. And then what we're doing ourselves is we're writing specific procedures to limit ourselves. So we're not going to be diving the Arkansas and the Mississippi River. We're not going to be diving Norfolk Lake. That's 130 feet deep. What we're targeting is dives that are typically about 10 feet deep, and that's the majority of them in the state. So low-risk dives, we're looking for a little bit of visibility. We're looking for low flow, and we're looking for not very deep. So that makes our risk very decreased compared to Arkansas or Mississippi River, where you can't see. You got a lot of flow. It's really deep. That increases your risk right there. And then we're doing 4-person dive teams. So we want one engineer a part of each of those teams. And so this is not a right now. This past year, this will be our second year of it. It's not that we have full-time divers, but that might be what we're looking for in the future. This is a summertime, late summer task that our heavy bridge inspectors get to do. Okay, and I kind of just talked about reduced risk, but our max depth is 25 feet. If you know from diving, your 33 feet is kind of your limit on where you might be susceptible to, to getting some nitrogen buildup. So anything less than that, you can come to the surface immediately. And then there we set a limit on 1 knot, what I was just talking about, and then debris. I think Graham talked about yesterday, if there's debris at a site, they'll let somebody know, the maintenance guys clean it out and then come back. So that's what we're doing as well. You don't want to be confining your space into timber that's all wrapped up. That is an increased risk. And then we're not going to be working on components. We're just going to be inspecting. And then, of course, we're not completing a dive if you're uncomfortable and unsafe. Okay, so kind of the inspection process. So what we were able to achieve last year and what we're going to try to achieve going forward is we're looking at 2 bridges per day depending on proximity. And so we're not talking about, Arkansas, Mississippi River. We're talking about these small crossings. And so the picture in the upper right is kind of our typical small crossing. You got four reinforced concrete columns in the water, and that's what the dive consists of. So we're wanting to inspect, to the high water mark, everything down, and then below the water line. So that's kind of our typical bridge, and if they're in close proximity, we can do about 2 a day, 1 in the morning, one in the afternoon. And so remember, we got 4 people, so 2 are going to be the dive team. So it takes a little bit of time to set up your equipment. What we've gotten used to is the 2 divers are setting up their equipment. And at Arkansas, we use a lot of drones now. So we got one guy that's flying a drone. The other guy is also watching the drone, making sure he's being safe around traffic. And then they're also taking, channel profile from or channel cross sections from the upstream and downstream. So they're preparing the notes. And they're also, the other couple of guys are looking for safety issues. We're looking for that debris. We're looking for, if there happens to be alligators. Luckily, we didn't see any last year. So we're looking and identifying risk before we ever get into the water. And then I have a video in here, but I don't think I'm going to play the video just for time. But I'm going to talk about it. We do use communication. So we have a buddy phone system. So a lot of consultants and dive teams probably have a similar system where you can talk like diver to diver, and then topside. You can be taking notes and talking to the divers there. And so this is kind of this is a good day where you can see some of the column. And interesting enough, if y'all take the underwater inspection class, there's they harp on you got to do a 10% cleaning. Well, why do you have to do a 10% cleaning? Because a lot of your columns look like that bottom left. That's a reinforced concrete column, and it looks like it's fuzzy. So that's algae. So you got to clean off a little bit of 10% or more to inspect the concrete underneath. So that's just you clear that out. The water gets hazy. You need to inspect after that. A lot of times, it's even worse than that. You're not going to be able to see anything. So you also can take underwater flashlights and be able to shine. And pretty much what you're doing is we're putting your face up against the column, and a lot of times we're dragging our face mask on the column. That's just part of it. And that's our face mask right there. One of our divers, and so the regulator goes into the face mask, and you got your buddy phone, kind of push to talk. I want to see if I can use the laser. There we go. So this push to talk button, so you push and you get to talk to either the other diver or to the top side. Of course, our regulator, and then these OTS masks, and then. But this is more like our typical water. It's very murky and muddy. You're gonna have little to no visibility, and then that's our dive team kind of getting ready. You see here, as a part of OSHA regulations, we have a completely separate air system. If our primary air goes out, you have an extra regulator and a small tank to be able to breathe to get back up to the surface. So safety stuff. We're going to skip the video for now. If we got time, we'll come back. Now, this is another good day in Arkansas, where you have a crossing here that it's like a lake. We got a lot of lakes around the state, and then you got two piers in the water, and these are probably, I think I remember this one being about 15 feet deep. So that's a typical good dive. This would be one of our deeper dives that our in-house crew is getting to do. And there you go, you got what we're seeing underneath the water. So it's a pretty low visibility. It's not like the Cancun dive that I got to do. Another typical, what photos we're seeing, some interesting things and why you want to have divers is because, like here, I see there's a hairline crack. It might be a CS2 crack on the surface, but I was actually diving this day and I followed this down about 10 feet, and the crack just starts growing and growing. So that's why we send divers down, because you want to be able to inspect the elements underwater, right? And you wouldn't have been able to see this, and it wasn't documented in the topside report because they're not diving. So that's some the reasoning behind why you need a diver. Okay, and then the inspection process. Like I said, this is that same bridge I showed a photo of earlier, and these photos actually came from that bridge. So the guys are taking, channel cross sections. You're going to be doing upstream and downstream, and then as well as preparing an inspection report. And one thing we were able to do when we worked with our consultants and our inspection software last year is that we're having our, any consultant that's working with us put everything in our inspection software, the same thing our in-house crew would do. So the reports look almost identical, and that's what you want. No matter which inspection team you send out to a site, we wanted the same product back. We wanted the same type of deliverables. There's some more screenshots of our process and the underwater inspection procedure, and then elements we're collecting. So interestingly enough, I'll just add this, FHWA requires all NHS bridges to have elements, right? Well, we do all state-owned for elements in Arkansas, but one thing we had to start doing this past year is we wanted to do element level inspection for all underwater inspections, even if they're county and city-owned. So that's what we're doing. We're putting in elements and taking defect quantities for city and county too. Those won't be submitted to FHWA. We're just doing that to keep up with the condition. Okay, so we're going to talk about some outcome and lessons learned. We've learned a lot over the past year. This will be our second year to do this. We're making a lot of improvements this year. So if you look at cost, and a lot of us talked about cost of in-house operations versus contractors yesterday, and there's a lot of reasons for that. But if you're looking at a similar bridge, and you take into account salaries, benefits, and everything, of course, we're not talking about overhead because we're going to have the overhead either way. It's about half the cost, and that's with any consultant. So we can do this for Arkansas can do this for about half the taxpayer dollar, I guess. And then if you look at statistics, and we looked at our criteria, remember everything less than 25 feet, less than 1 knot, and no high risk, right? That's about 75% of the bridges over waterways in Arkansas. So most of these can be done with our in-house crew. But I want to make a statement here that we still rely heavily on consultants. We're not going to be doing these high-risk dives, and if we get in a bind with employees, we can always call on consultants. So consultants are important. I'm not getting away from consultants here. We rely heavily on them. So also we have local knowledge and coordination with topside inspectors. So we work directly with our district inspectors that are doing the topside inspections. So when we're doing these, we're often talking directly with the inspector that inspected the topside and coordinating our underwater inspection. So having that direct line of communication is beneficial to us. And then we get enjoyment out of it. I'm a diver myself, and I love going underwater and being able to inspect. So there's a sense of pride and enjoyment in the job duties that our inspectors and engineers actually get to dive. So that's a plus for us. And then what we're gonna be able to do now is have a quality assurance on our on consultants, and then also have a quality insurance on our in-house dive team. So like what we're thinking about doing going forward is if we do have consultants, to be able to send out our own crew to do a quality assurance inspection and making sure that stuff lines up. Same thing with our in-house crew. If we have one team do it, we have enough divers that we can send a completely separate team and be able to make sure that the information is lining up. All right, so areas for improvement, and we're going to be making a lot of improvements this year with our dive operations. So kind of what I was just talking about, our QA dive team will be able to QA consultants. Now we're not going to be hopping in the Mississippi River in Q&A, QA and or doing a quality assurance check there. But there's certain bridges, down to a certain depth that we can do a quality assurance check. And then we want to increase our use of underwater cameras. So GoPros are awesome. Not supposed to advertise for products, but GoPro is the way to go. And then also increase training and safety training. So we're working with a consultant right now to help us improve our, in-house certification process. So to meet certain regulations to make sure that this, inspector that wants to dive, and even though he passes a medical exam, make sure that he is, qualified to dive based on, physical conditions and other things. And then we want to spread out our dive workload over a 5-year period. So last year we were in a plan of corrective action. We had 12 months to get them all done. Well, here in 5 years, we don't want to do them all in 12 months. It's a pretty big undertaking. So we want to spread these out. So move some of them up, pretty much. And then we learned another thing, that it's best to wait till mid to late summer for better diving conditions. If you're hopping out in the water in May in Arkansas, for one, it's cold, or two, you might be diving 2 or 3 times as deep. So let's make it easy on ourselves. And then also we want to incorporate our sonar. I've given presentations in the past, and I think a couple of years ago I talked about our sonar, our multi-beam sonar, and I think Michael will be talking about some sonar. So we want to incorporate sonar with our underwater inspections. And then also we're looking at an underwater drone. So being able to send a drone down before we do an inspection as a screening tool, I think will be a huge benefit. So with that, I'm gonna open it up for questions.
Yep.
Questions? Okay. Yeah. So how many bridges total that we have? So we're right now we're still adding some based on water conditions. Right now we have about 215, I think. The exact number I'd have to look up, but about 215 bridges that require dives. That's probably going to go up to 250, 260, because some of the topside inspectors are saying, hey, we probably want to look at this one because it's at that 4 to 5 feet mark, that we've obviously heard from Graham that there's issues, and you want to get somebody out there. I also want to add a point that, and I talked about it a little bit earlier, yeah, this is a dive team, but a lot of times it's me and the inspectors, or the inspectors throwing on a snorkel, and you can do it mostly with a snorkel. If you're at that 4 to 5 feet mark, instead of putting on 50 pounds of equipment and lugging it around in the mud, it's best just to throw on a snorkel and get it done.
Got a question about the element level information that you're collecting for the cities and counties. Do you think that there's a value? I mean, what is the value that Arkansas is seeing from that? We're debating collecting element level information for piles, and I guess want to get your perspective on why you decided to start collecting that.
Yeah, so that's a good question. So we're talking about value in collecting element data for cities and counties. And we're just doing this for our underwater, so we have questions about, possibly doing it for piles. The value we see in it is I guess, repeatability. So the next time we send an inspector out there, they're keying in on the specific condition state of that pile. Did it change, or did it stay the same? With a pile, even though you have more section loss, it might stay in the same condition state. So there might not be as high of a value as the note. The note would be the highest value. But that's kind of where we see it. Not that we're giving the data to the cities and the counties, so that the cities and counties aren't really using the element level data, and they probably don't even understand it. But I think the value that we see in it is repeatability, and just having the diver pick up on, hey, I need to pay attention to what condition state this column is in, this linear foot of pier is in, stuff like that. Good question.
Kevin, we've done something real similar in West Virginia. I'd say over the past 3 years, I think we've done 100% of our dives in-house. Like you, we don't plan to do all of them, but we can do the majority of them. One question was, how do you coordinate the element level? You guys are doing underwater. The regular inspectors are doing the condition states for above the water. How do you guys coordinate that and getting those resolved?
Yeah, so that's a good question. I'll even add to that. You got to coordinate the condition rating of substructure too. What we're doing is the worst controls. So like I mentioned earlier, we have a relationship with topside inspectors. So if we can't get the information from their previous report on where that defect was, it should be in the report. So if they called out a defect in the cap and they're rating the substructure lower due to that, but we're not keying in on that, we will have a conversation with them to put in the worst case condition state defect as well as the worst condition rating for the substructure. So we are going for worst, but we are keeping the condition ratings separate in our software. So we set up separate fields, and now you kind of have to with the SMBI, but you will have an underwater condition substructure rating and a topside substructure condition rating, and we're taking the worst and submitting the worst to FHWA. Good question.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.